Hi, this is a demonstration of how to set up virtual servers using the live image. What you are seeing right here is the GUI of the live image. I'm doing this using a virtual machine already, so that I can do the screen recording without having to rely on the live image itself. But you don't have to worry about that. I'm assuming that you already have the live image burned either onto an SD card, USB thumb drive, external hard drive, or some other device so that you can at least get to the GUI of the live image. So we'll go ahead and log in as user, and the password of user is user. And because this is before we actually set up the persistent partition, so it will ask us about those questions that it normally does. Okay, so now we have the full GUI. We just logged in to user using the GUI of the live image. The first thing we want to do is, the first thing I want to show you is to show you, how to use mount and find out that we actually do not have a persistent partition at this point. Because if you look at the mount point live cal, you can see that it is mounted on tempfs, which is a RAM disk system. So that means whatever I save at this point is not going to be saved on any particular device. It is just going to be saved on the RAM disk. When I reboot the machine, all of that stuff will be gone. So it's time to set up a persistent partition, and I'm going to use the third drive for that purpose. Okay, so we'll go to gpod and enter the password of the root user, which is ball, B-A-L-L. And now we have gpod. Now with gpod, the first drive, even though it says unallocated, that's my pretend internal hard drive. And most of the time, SDA is going to correspond to the internal hard drive. Your removable drives usually would map to SDF, SDG, SDH, and so on. So in this case, the drive that will contain the persistent partition is going to be SDC, which has 4 gigabytes, and it is all unallocated at this point. So I'll go ahead and allocate it right now. So click on the unallocated portion and click new to create a new partition. Now because this particular device is going to be dedicated for this purpose, it's complaining about a partition table is required, and we'll go ahead and create a partition table first. So we'll go ahead and create a partition table. I don't think you have to do this because if you use anything that have been used for anything, there will be a partition table in the first the first sector of the hard drive. This is a virtual hard drive, so that's why I have a problem like that. So now we can create a new partition, and I will take the entire drive in this case as one single partition. I will change the file system to extension 3 and make the label live-rw, and everything checks out. Click add and then click the check mark. Now before you click the check mark, you definitely want to double check and this is in fact the device that you want to perform these operations on, because once you do this, there's no way to undo it. If you damage an internal hard drive, you can potentially lose the entire installation of Windows, which is not going to be cool if you need that. So we'll go ahead and apply all the operations. It gives us one last chance to back out of the deal, and we'll go ahead and apply. And this shouldn't take too long because, okay, never mind, it did not take too long. Alright, so now we have a partition dedicated to the persistent data. And there's no way, well, I guess there may be a way to do it, without rebooting. But since I don't know how to do it, I'm going to reboot the machine so that, everything will be fresh. So we'll go to, we don't have to do that. We actually can do it all on the command line. Change to super user or the root user, and then you just type reboot, and it will restart the system that way. And now we are restarting. and I have to boot from the second device again. So I press 2, we get back to here, and we select live persistent again. But this time, because we have already made a partition with the label live read-write, this time it will use that partition, and I'll show you, how we can find out whether it is actually using it for the persistent partition or not. If you read the messages, carefully, it actually shows you that it finds live read-write and is mounting that as the cow mount point. But the messages, fly by really fast, and most of the time, we don't have enough time to actually catch that. So that's okay. We can check it later. Alright, we are back into the GUI of the live image. And once again, we log in as user, because that's the only account that is available at this point. And I will show you a way to get rid of that annoying message at the beginning too. Now this time, whatever we do is going to be saved. So this is our chance to fix everything, to get rid of most of the problems with a fresh live image. So we'll start up a terminal again. The first thing I'll do is to change to super user or the root user, because all of the things that we're going to do here will require root access. The first thing we want to do is to change the time zone. When you use the command date, it shows you, the current time, but the current time, as you can see here, is in UTC, the Universal Time time zone, and we want to change it to the local time, because otherwise you have to do all the time conversion in your head, and it's not healthy if you do that too often. So what we'll do is we'll reconfigure that to use the local time zone. To do that, you have to run this command, dpkg-reconfigure. That's a configuration. That's a reconfiguration command so that we can actually change the setting of some of the packages. And the package that we want to reconfigure is called tzdata. Like that. You press the enter key. It will rerun the initial setup, and this time we'll pick US as the geographic area, and then within the US we want to pick Pacific as the time zone, and you press the enter key, and now everything is fixed. The clock here will be updated, next when it moves on to 55. So we are all done with the time zone, and remember, everything is going to be saved this time, so the next time we reboot the system, we don't have to do this again. The next thing we want to do is to create a new user, because I don't want everybody to turn in the homework assignment and everybody is just a generic user. So we want to change that. We want to add a new user, just for homework purposes. We'll use this particular user account. So in this case, I'm Tak. My last name is Anyang, and I'll just use that as my username. And it will ask me for the password, or the initial password of this user. I'll just pick my usual. There we go. And there's no need to really enter all that data. And now we have a new account called TAUYEUNG. And we don't have anything else to do, as root at this point, and we don't have anything to do as user either. What we can do now is to log out from user and then log in as in this case, T Anyang, and we'll do everything else using that custom account name. So we'll go ahead and get rid of this terminal emulator. One way to get rid of it is to click the X button here, and the other way, which I think is faster, is just to type Control D. Control D means end a file in Unix. In this case, when you tell a terminal emulator this is the end of everything, that means you're telling the terminal emulator to also close, just like that. It's Control D, and then we'll go to the application menu, and then select log out. And we don't want to restart the system. There's no need to restart at this point. We'll just go ahead and log out of the system. When you log out of the system, it actually restarts the GUI environment, but you can see that this time we have user, which is the generic user account, and also the new account that we just created. So we'll log in as TAUYEUNG in this case, supply the password, and it will ask you this, it will complain about the domain name is not doesn't have an IP address. We'll fix that this time. I forgot to fix it as a generic user, but we can fix it now. Okay, and we'll go ahead and open up the terminal and change to super user. Remember the password is ball, BALL. And what we need to do is to change a file called etc/hosts. This is a file that contains the name and the IP address of certain domain names. And what we want to do is to say 127.0.0.1 is also known as localhost and Debian, because the machine name is Debian here. So we want to make sure that that's understood. So to test whether this is effective or not, let's go ahead and just exit and log out, and then log back in again and see if that message is still there. And you can see that message is completely gone, because now Debian actually resolves to 127.0.0.1, which is a valid loopback IP address. Alright, so finally we are now ready to set up a virtual machine as our server. So we'll go ahead and start the terminal again. And before we do anything else, what we need to do is to allocate the space that we need for that virtual machine. And I think it is better to set up a folder to put all the files related to a particular virtual machine, so that they are more contained that way. So in this case, I will just make a folder for this particular virtual machine. So we'll call it, as a generic name, we'll call it virtual machine 1. And then we'll do everything in VM1 in this case. Now, the first thing we want to do is to create a disk image file for the virtual machine. The disk image is a single file from the host operating system's perspective, but to the guest operating system, it is a physical device. So what we need to do is to run a command to do it. And if I remember correctly, it's called kvm-img. And there are, if you just type the command, it shows you, the options and what you can do with the command. You can also type man kvm-img, which will display. Well, okay, we have to look up qemu-img instead, because kvm is derived from qemu, and a lot of the help man pages are still using the old name. Okay. So qemu-img, which is also known as kvm-img, has all of these particular commands. What we want to do is to create. So now we have to specify create. It is optional. Whenever you see the square bracket, it is optional. So we can specify the actual the format. We can choose amongst several type of formats. The options, I don't think we actually need to do anything about the options. The file name, we definitely need to supply that, and we also need to specify the size as the last item. So what I want to do now is to find out what formats are available in this case. Now in this case, because man, or the manual program, is running in page mode, you can actually use the keyboard page up and page down key to go back and forth, or if you prefer the VI commands, it is Control F for forward and Control B for backward. Some people find it awkward, and other people find it to be quite handy because the editor VI also used the exactly the same commands. All right, so FMT is the disk image format. It is guessed automatically in most cases. So we'll go here, go down a few pages to find out what are the options, because some of these options are quite interesting, and some of these are actually very useful too. Okay, the first one is raw, and which is the default. I think for our homework assignment and for our project, we should use raw. QCOW2 is good. Okay, this is QCOW2 right here. Now QCOW2 is good because it will create a file disk image that is only as big as necessary. In other words, you can try to allocate a file that will represent a physical drive that has 20 gigabytes. But the QCOW2 file can be only, maybe several megabytes at the most, because it depends on, which part, how much of that virtual device is actually in use. So if you're, if you want to save space, QCOW2 is a great way to save space. But there's one drawback with QCOW2. It can grow. Okay, if you allocate 20 gigabytes for the virtual device, it can potentially get up to 20 gigabytes large. And if your actual drive, or if your USB drive actually does not have 20 gigs of free space, then you can run into a problem as the file tries to grow to its maximum potential. So that's why I don't want to use QCOW2 in this type of situation. QCOW has basically the same properties. If you want compatibility with VMware, you can pick VMDK. I guess that stands for Virtual Machine Disk. And here we have the Linux C loop or compressed loop image, which is only useful for CD-ROM images, so we're not going to use that. And after all this discussion, the conclusion is we'll just use the default, which is raw. Okay, so now let's go back to the command itself, and we have to specify create as the command. There's no need to specify the format. We specify the file name, and I would use .raw as an extension to remind ourselves that the disk image is a raw image. And then we have to specify the size. Okay, so we'll go ahead and do that. kvm-img create, and then we have to give it a file name. The file name is not really that important. It's just that it has to make sense. So we'll just go ahead and use disk img.raw, and then we have to specify the size. Now, when you use the raw image format, if you try to allocate the space for a let's say 10 gigabyte device, it will use up 10 gigabytes right away. I mean, it will allocate a file of that size. So which is good, because now you use up that much space on your USB device or on your compact flash or SD card, and no one else can use that space anymore. Okay, so from that perspective, this is a good thing. In this case, I'll just go ahead and specify a 2 gig drive, which is more than sufficient for this demonstration, and press the enter key. Oh, okay, it doesn't want me to use kvm-img because it wants to go back to use the old name, which is qemu-img. Now, let's go ahead and take a look at the files that we have at this point. You can see that the file that we just created actually does have 2 gigabytes. Okay, it's because we have K, mega, and giga here. So this file, in fact, has 2 gigabytes. Okay, so now that we have this file, the next thing we have to do is to figure out how do we invoke the virtual machine command in order to specify this as a hard drive, because that's what we want to do. But even more importantly, how are we going to run this, run the virtual machine so that it can actually boot from the installer disk? Okay, because that's the other problem is where is the installer? Well, let's just type kvm and press the enter key and see what happens. Okay, because in this case I'm trying to run a virtual machine, but without actually specifying where's the CD-ROM and where's the hard drive and stuff like that. So when I press the enter key, it gives me this screen here, and it simply complains. Okay, we have a little bit of a cursor control problem because it is a virtual machine inside a virtual machine, and I'm thinking that's part of the problem of cursor control. Anyway, it cannot find any device, and that's normal because I did not specify any device. So we'll go ahead and close it. Okay, it's perfectly safe to close it because it is not opening any particular file as the disk image. So next, what we want to do is we'll go ahead and run kvm again, but this time we specify where the CD-ROM is. And this is the interesting part. The CD-ROM is going to be our CD image, our live image itself. So in order to find out where is our live image, let's go ahead and run the command called mount, and this will show us where it is. So you can see that live image is SDB1. Now we don't want to specify live/image as the CD-ROM drive. We want to specify SDB1 as the CD-ROM device, okay, because we are just using SDB1 to serve as the actual CD image to the virtual machine. Okay, so that's good. That's relatively easy. So kvm-cd-rom /dev device SDB1, which is the partition that contains the actual live image. And let's just do it like this. Okay, the thing about learning how to do something is you don't want to do many things, many new things all at once, because if you did that and something does not work, then you have no idea which part of the experiment caused it not to work. So we want to just add or change one thing at a time, and then we press the enter key. Could not open disk image, permission denied. Yeah, that's because when you do a ls-l, this is normally something that only root has access to. So I'm going to teach you another trick to get around this problem. We will have to get to the permissions sooner or later, but now I can give you a quick preview just so that we can handle this in the future. Now you can see that these are the permissions of the file. It's a special file, it is a device file, but nonetheless it is still a file. It has to play by all the rules of file permissions. This part here, rw- is basically saying the owner of the file has read and write access to it, and the owner is root. Now root by default has access to every file anyway, so that part is not really that useful. The second set of characters, rw- refers to the group owner. Every file has a user owner and it has a group owner. In this case, the group owner is disk, which is a group in Unix. So if any member of the group disk also has read-write access to this device. So that means if I want to fix this problem, I can just say add user and the account name and also the group name. Now I cannot do this without changing to super user first. So let me go ahead and change to super user and say add user TAUYEUNG, my account name, and also the group name, which is disk. Okay, it's all done. I go back to my regular user account, and you would think that things should be done at this point. Well, let's go ahead and check. It's still complaining. Well, it's still complaining because every time you log in, the permissions or the file, I should not say permissions, the group ownership, it just take a snapshot of the group ownership when you start up the shell, and it will stick with that for the duration of that shell. And that's why we have a problem here. And to fix that problem, we can just go ahead and get rid of the shell, start a new one, and try that again. Oh, we have to change to that folder first. So the folder is called VM1, and then we try the same command. So I'm just using the up arrow key to locate the command, and it is still complaining. Oh, okay, I might need to log out and log back in again. because it may not be just the shell, it can be the entire login session. So we'll go ahead and log out and then log back in again. There we go. And change to VM1. Aha! That fixed the problem. And you can now see that we have a virtual machine running inside the live image. And to me, because I'm recording this as a virtual machine, the entire thing is a virtual machine. So now we have a virtual machine running inside a virtual machine, which is kind of cool. Alright, so getting back to here, we don't want to run live persistent anymore, because we're trying to install Linux onto this virtual machine. So what we want to do is to select installer. But this time, if you pick installer, it's not going to be very helpful. The reason why it's not going to be very helpful is we did not specify a hard drive. So where are we going to install Linux? Well, we'll go ahead and have to close this again, because now we have to go back and specify the actual device. Okay, which is not too hard. So we say kvm-cd-rom, and then what we'll do is we'll specify the actual device, and in this case it's going to be HDA. So this means this is going to be the primary hard drive of the first IDE controller. And then we specify the file, the image file that we just created in the previous step. And this time it will run correctly. Okay. It will locate the startup image, and then we have to select installer to run the actual installer. As I'm watching this, I'm still amazed that I can run the virtual machine inside a virtual machine. It's just cool. Although it will be a little bit slower this time because the virtual processor of the live image does not have the virtual acceleration bits. So it will get slower and slower as you nest virtual machines inside virtual machines. As you can see, this normally would not take this long. Alright, we are now in the installer. Excellent. We'll take the defaults. We'll pick English as the installer language, and it is the location is the United States. And it will ask us about keyboard information. Key map to use is American English. So I'm just taking all the defaults by pressing the enter key. And it needs network access because it's going to pull all the files remotely from the Debian server. So that's why networking is very important when you install using this method to install Debian. It's doing DHCP, everything is good, and the host name. Now this part is up to you. How do you want to name the new system? I would not use Debian. Okay, I would make it a little bit more distinct. Actually, in this case, because I named the folder VM1 Virtual Machine 1, I'll just use VM1 as the host name. So this way, when you look at the login prompt or when you look at the prompt of the command line interface, you can know immediately which virtual machine you are using. Okay, and there's no domain name in this case. We'll press the enter key, and now we can specify which Debian archive server do we want to use or the location of that. You are free to pick some other countries, except that won't be very fast. So I encourage everybody to pick the United States here. And within the United States, there are many mirrors, and you can pick one of these mirrors. I sometimes go select Berkeley, because location-wise, Berkeley is closer to us. But you can pick anything you want. It doesn't really matter. Should not. Okay, we don't have a HTTP proxy in this case, so leave it blank and just press continue. And now it's actually downloading additional packages and files that it needs in order to install Linux. And it's going to do this slowly because it's going through the virtual machine, and the virtual machine itself is running in another virtual machine. But it looks like it's actually stalling. So let me check the actual host environment and see what is going on here. Let me check one thing and see if I can actually go online with this. I have a little bit of a problem here because I cannot take the cursor out because I'm running a virtual machine inside a virtual machine. When I press Control Alt, it's actually getting out of the original virtual machine instead of the virtual machine inside the virtual machine, and that's why we have a little bit of a problem here. Oh, okay. I think I just got it. Cool. And what I want to do is to see if I can go online inside the host, inside the live image environment. Looks like it doesn't have any problem going online, so let's go to the Debian website just to be sure. Yep, it doesn't have any problem inside here to go online. And so this part should not be a problem either. Okay. I think it just hung up on me. So I'm still having problem controlling which window I want to access, because of the virtual machine inside virtual machine issue. Oh, okay, it just found it. Okay, alright, so we'll let it do it. This might be a whole lot lengthier than otherwise. Well, as the system is doing this, why don't we go somewhere else and take a look at I forgot I don't have good control of the cursor. What I just did is to get to the monitor mode of the original virtual machine and see if I can do something about this problem that I'm facing right here. It's doing this very, very, very slowly. I have a better idea. Okay, let's do this. I'm going to stop the recording, Actually, I don't need to stop the recording. This is what I'll do. Let me see if I can at least get out of the virtual machine inside the virtual machine. It doesn't let me control the cursor, that's the problem. Okay, let me try this. Okay, that gets me out of but the mouse, the actual mouse location is, can still be somewhere else, somewhere other than what I want it to be. So we still have that problem. What I want to do is to close the virtual machine inside the virtual machine, and I'm having a little bit of technical difficulty here. So when I specify Alt Tab, it's actually just switching my actual desktop and not doing anything about the virtual machine here. So I have a little bit of a problem here. Well, guess what? This is what I'll do. I'm gonna force the virtual machine to stop like that, and then we'll go ahead and run it again. But this time when I run it again, I'm just running a virtual machine using that same command that I show you. So so the demonstration is still okay, except we'll have to restart it as a part 2.